Okay, welcome back. Before break, we did decomposition. Okay, so we said original data equal to trend times trend T times S seasonal times cyclical times irregular. This is we did decomposition. And the next, we are going to use this decomposition to make a forecast. So this is example 5.4. Okay, to forecast sales for the fourth quarter of 2007. Okay, remember that data for your reference. This is original data here. Those are the sales data. We have time period 1, 2, 3 until the last data is 28. Okay, period 28. Now you are asked to forecast the first quarter for the so let's do the first quarter first. Okay, should be, let me see. So forecast for T equal to 29. That is our task. So the original data up to 28, we are going to forecast for 29. Okay. So again, we need to calculate the 4 component T, S, C, I. Okay, so the first component T is the trend. The textbook equation shows it is 261.24 plus 0.759 T. So you plug T equal to 29, you get the T value. Okay, you get T value 283. And next, you need the S. S is the index, seasonal index. And that is a 0.77. Nine, 6, 7. Okay. And then you get C. Cycling C is a cycling effect. Sometimes to simplify the forecast, we just assume it is 1. Same as the irregularity, I is also 1. We just assume to simplify the forecast process. Okay, and then you do the forecast for period 29. You make multiplication of all these 4 numbers together. Okay. All these numbers together, you get a final answer. Okay, it is 220.842. So any questions for forecast? Any questions? All right, so that concludes our presentation for chapter 5. The examples, the concept, and the techniques. Next, let's do some problems from the textbook. It is question 1. Explain the concept of decomposing. Why we need decomposing? Any ideas? So the concept of decomposing is to decompose the data into different components, trend, seasonal, cyclical, irregularity, in order to get the inside cause of the variability and to make the forecast. Question 2, explain when multiplicative decomposition is more appropriate than additive decomposition. You use multiplicative when variability increased over time. If the variability is constant, if it is constant, you use additive. Question 3, what are some basic forces that affect trend cycle of the most variables? Why data like trending up and has cycle? Why is that? The basic forces means economics forces. Okay. For example, the population growth, the advancement of technology, inflation, okay, productivity increase, all cause the trend cycle. Question 4, what kind of trend model should be used in each of the following cases? Case 1, variable is increasing by a constant rate, not a constant amount, it is constant rate. If variable is increased by constant rate, you should use exponential. Okay. Second, B, variable is increased by a constant rate until it reaches saturation and then levels out. Okay. And this one, you use the textbook called growth model, growth curve. C, variable is increasing by a constant amount. This one you use linear. We did a lot today for linear. Okay. Okay, question 5. What are basic forces that affect seasonal components of the most data? Why data appears seasonal? Most often it's because of the weather. Sometimes it's because of the calendar. Okay. Question 6. Question 6, we need data. Okay. In PowerPoint slide I posted on D2L, you can just copy this data. So you see it is PowerPoint. You copy, select this data, copy, and then paste into your Excel. Okay. So what are we going to do with this data? It is a capital spending. Capital spending. Okay. Question A, plot the data and determine the appropriate trend model. Question B, if the model is linear, compute the linear trend model for years of 77 to 93. Okay. I give you a moment to see if this is the question, are you going to do it? So first we get the data. Okay. This data is P6. Chapter 5, P6 here. Yeah. So I just save this, save as. My initial. All right, to create a trend model, you need to add a column, insert time t. Okay, from 1 to. And then you go in, select those two columns together, go insert, line chart, scatter all, this one or this one. And then you want to create the equation, right-click your mouse. Right-click your mouse, add trend line, display equation, display R chart, R square. So this way it is easier than data analysis. You get this equation. I'm just going to move this and try to increase the font size. Okay, so this is the equation. So we plot the data. We said it is a linear trend mode. And then it is compute the years for 1977 to 1993. So we are asked to compute the linear trend model. Okay. So once we get that equation, basically, so compute. So actually you are doing y hat, compute y hat. Okay. So equal 23.895 times x, x is t, plus 218.48. That's it. That is the equation to compute y hat. Okay. And then just drag it down. So you compute it. Okay. So that is question B. And then actually have question C. Question C. What is the average increase in capital spending per year? Question C. What is the average spending per year? That is question C. Question D, estimate the trend value. Estimate the trend value in 1994. Okay. So let's do those two questions. Question C, what is the average spending per year? The answer is the slope. What is the slope of that equation? Okay, the slope represents one average per year. So what is that slope? Maybe I want to copy this into OneNote. So the slope is 23.89. That is answer for question C. And then estimate the trend value for 1994. Okay, 1994. So for period 18, okay, so you just drag it down. It got the number, it is here, 648.5. That is for 1994, period 18. Okay. So it is equal to 680 if you keep the whole number. All right. So any questions? We went over some problems. Any questions? All right, so we have some time. We can just go over some midterm. Okay. Remember, it is all multiple choice questions. Some questions are concept questions. Some questions need calculation. Okay. So for normal distribution, you need to know the standard normal distribution, mean is 0. Standard deviation is 1. Okay. Found the Z value given cumulative standardized normal distribution. The cumulative standardized normal distribution, it is just a probability, or it is the area, the same thing. Okay, means, for example, if I give you, let me see, depending on the area, if I give you this area, I said this area is 0.87. I ask you, what is this Z value? You need to know. Okay, so let's do the Excel. Let's open a new worksheet. Increase the font size. So you use norm dot inv because you want to find the value. Oops. Just try to move the screen. Sometimes I cannot move it. Don't know why. So equal norm dot inv. Probability is the area. It has another name, cumulative standardized normal distribution. So if I give you 0.87, mean is 0, standard deviation is 1, and you get this value. So z equal to 1.12. Okay. So you use z equal to norm dot inv 0.8701, and you get a number. The point estimate. When you estimate a population parameter, for example, you estimate population mean, but you only have the sample data. What do? You use the sample average to estimate population average. So use the sample mean x bar, estimate population mean mu. That is the point estimate. Those actually in chapter 2, okay, chapter 2, and also CQMS703 concept. And the next one, confidence interval estimate. When you have confidence interval estimate, you always targeting the population. Okay. So if it is normal distribution, if depending on it is normal or student distribution. So this question connected to with this question, you need to distinguish normal distribution or Z distribution with T distribution. You use normal distribution when you have a large sample data or when population standard deviation is given. Most often, you will use T distribution. So when you use the normal distribution, the confidence interval formula use x bar plus minus z half alpha times s over square root of n. And when you use T distribution, the confidence interval becomes x bar plus minus t half alpha times s over square root of sample size. For critical value, I already did one example for Z. By same token, you can do the example for T. Okay, so for example, if you are given alpha 0.05, and you know this is two-tailed test, and you know sample size, for example, 30. The question asks you, what is the critical value for T? Okay, so you use Excel. You need to go over this in chapter 2, okay? So you go T.inv, okay? Because it said two-tailed, and the probability, you are going to use 0.05, that is the alpha. Degree of freedom, sample size 30 minus 1, that is 29. and you get 2.045. Okay, 2.045, that is critical value. Next is the regression output from Excel. We did it today. Okay, remember those, yeah, this table here, very, very important. The summary output, the ANOVA table, and the last table here. Every number in this table is important. Okay, and I give you detailed explanation here, see? Okay, so that is referred to this part. And then linear trend regression model, we did it today. Oops, battery is low. Sorry. Right. We did a lot today for regression out for linear trend regression model. Okay, we did it today. Last class, we did a lot calculation for MAD, MSE, MAPE, MPE. Last class. And today we did the seasonal index. At the beginning of class, we did moving average exponential smoothing. Okay, and review last class for double exponential smoothing, and for Winter's multiplicative smoothing, last class. And this autocorrelation, the first two class. Okay, so although it is covered chapter 1 to chapter 5, but I hope you will focus on the area I pointed out here. Any questions? All right, that concludes presentation for today. Remember, you can always email me for any questions. Please allow 2 business days to have your email answered. Okay.
Professor?
Yes.
I have a question here. So like on the March 1st, we're gonna attend the Zoom meeting first, and then you will provide us with a link, or how do we assess the test one?
Thank you so much. On the March 1st, you just go to the course website. You do not need to attend the meeting. You do not need to sign in to the meeting. You directly go to website, and then you go to, let me show you where do you go. I assume you all had experience writing the online test, okay?
Yeah, usually professors like ask to log into Zoom sometimes, just so like if you have any questions about the exams, do we need to log into Zoom, or can you just do the test?
You just do the test. You have questions, you email me. I am closely monitor my email. Okay, so you go to our course website, you go to assessment, and then you go to quizzes. After that, you pick test 1. It is not available yet. It will open probably 10 minutes before it is available on at 6:20. 6:20. It is 90 minutes, 1 hour and a half. Okay, and the questions are randomized. Your question 1 is not the same as your friend. Okay, so each body have different question 1, and also the answer is randomized. So make sure do your own work. Okay, the question is non-prevent the backtracking. So means after you do question 1, when you do question 2, you cannot go back to question 1. Okay, it is just straight. It's just one direction. You cannot go back. Okay,
sorry, Professor, how long do we have to do the
1
exam?
hour and a half.
And are the questions long? Like, is there a lot of calculations involved?
Not very long questions. Some questions are concept. Some questions need calculation. Okay. Any other questions? I will make announcement for the test on D2L. Okay. All right. That's all for today. Thank you so much for your participation. Good night and good luck for our test. Also have a great reading week. Okay. Bye.
Sorry, Professor. Hi, can I just ask you a question?
Sure.
So I asked the question regarding my Excel kind of problem before. Would